Hi everyone and welcome to the videos. So today I'm going to look at chapter 1. So in the textbook, chapters 1.1 through 1.8 are actually put together. So we do all of them at once. It just goes through a lot of terminology that you're going to see time and time again throughout this course. So we just kind of put it all together, and the homeworks are all put together as well. So chapter 1 is basically an overview of what you're going to see moving forward. So we look at exactly what is a statistic. We're going to look at populations and samples and why these things can be useful to us. What are we trying to find from these populations and samples? Okay. So first of all, kind of linking this biblically, we actually see in Luke chapter 1 verse 3, he says that when he wrote the gospel, he carefully investigated everything from the beginning. Okay, so he investigated stuff. He wanted to find out stuff to make sure that what he was writing was accurate. Okay, so we have to make sure, just as Luke did in the Gospels, we have to make sure that we always have accurate information that we are dealing with in order to prove our point. Okay, so we have to always make sure that we start out with accurate data, we then summarize it, and then we can use the summary, in this case statistics, in order to prove a point that we're trying to make. Okay, so we use those statistics to show a fact about a particular set of people or a particular set of things. Okay, so statistics gives us the tools that we can use to investigate data. Okay, so we can get a set of data, we can summarize it with statistics, and it allows us to basically make an informed decision about that data. Okay. So normally when we are looking at something, let's say, for example, I want to know in America how many people are brunette. Okay. When you look at that, you're looking at the whole population of America. Okay. So the population is the larger group that you are trying to study. So I tend to do this with a picture. Okay. We start out with this very large group called the population. Okay. And the population is the large group or the largest set of things or people, okay? Okay, so 9 times out of 10, whenever you get a problem and we're looking at populations, it's normally looking at people. But I mean, you can get, let's say, the population of things being made in a particular factory. Okay, so it can be things or it can be people. But what I need you to take away from this is the population is the largest set of things that you are actually looking at studying. Okay, we want to find something out about this very large set of data points. Okay, so from that, the next term that we're going to use is the frame, okay? A frame is just a list of people or things in the population. So, for example, if the population that I was looking at was all the people in the US, okay, the frame would just be a list of everyone's name. So it would be 324 million names, okay? So a frame is a list of everyone or everything in the population. Okay. And the last term that we need to know about a population is something that you're going to have heard many times before, is a census. Okay. A census is just a survey of everyone in that population. Okay. So a census is a survey of everyone or everything in the population. So I would take a census of a population in order to find out a particular fact about the population. So I could take a census on the population of all the people in the US to find out how many of them were brunette. Okay, so a census is just a survey. Now, we conduct a census in the US every 10 years. It's being conducted this year, and basically they want to know about everyone that lives in the country. There are some issues with this, okay? The two main ones is it's incredibly expensive to do, okay? Trying to survey 324 million people and trying to reach them all is incredibly expensive, okay? You've got all the postage costs, you've got when people don't reply, you've got the interviewer costs, you've got the cost of running all of this data through a computer. It's incredibly expensive, okay? The other problem with it is, of course, the time constraint. Okay, trying to get to 324 million people, okay, it takes the entire year. Okay, this is why they only do it once every 10 years. So it's incredibly time consuming. So because of those two main reasons, we normally don't like to survey an entire population. Instead, what we do is we survey a smaller subset of the population. So instead of looking at facts about a whole population, what I'm going to do is I'm going to take this smaller subset of the population, and that is called a sample. Okay, and it's just a smaller set of things within the population. And what I can now do is I can survey the people in that sample instead, and I can use the data that I find from that to extrapolate it and say, okay, because this was the case in my sample, I can therefore say or assume that therefore this is true for the entire population. And this is what they normally do whenever they conduct surveys. You don't really want to conduct a survey on everyone in the population. It's just too time consuming and too expensive. Okay. Just be aware when you take a sample, we're going to do more about this in a later chapter. Two things that you have to have when you have a sample, okay? It's no good taking a sample of people out of the population that are all exactly the same. So, for example, I came up with the idea of, let's say I wanted to know how many people in the US were brunette. Well, that's no good if I've picked a ton of blonde people to be in my sample, okay? It just doesn't work because it's not a representative sample for my whole population. So the first thing is I've got to make sure that my sample is representative of the whole population. Okay. Otherwise, if it's not a representative sample, my data is going to be skewed and it's not going to give me something that I can then infer about the whole population. Okay. So it has to be representative. The way that you normally get a representative sample is to make sure that it's randomly selected. Okay. So it's got to be representative and it's got to be random. If you've got a random sample, okay, so if I've just picked random people off of the street, I'm more likely to get a sample of people that are representative of the whole population than if I just, let's say, went into the classroom and just picked one classroom worth of people, okay? I probably won't get as representative a sample. So if you make sure that it's representative and it's randomly selected, then you are more likely to be able to infer something about the whole population by just surveying that sample of people. Okay. There is actually a great video that looks at a population, a sample, how to take a census, and when sampling is really, really useful. It's by a company called Against All Odds, and we're going to do a few of these videos throughout the semester. If you go to the Blackboard page, I've actually put it on here. So the Blackboard page for the class, if you go to the menu at the side and scroll all the way down, there's two tabs here, Against All Odds Videos and Against All Odds Video Clips. In this case, it's actually in Against All Odds Videos. And the first link that is there is a video about census and sampling. It's about a 10-minute video. But it looks at how the United States conducts their census, the problems that they run into, and the good things about taking a census. And then it also looks at sampling within a factory and how they do that, how they pick a sample within a factory to make sure that they've got good quality control. But it's a very, very good real-world example. So I would encourage you to go ahead and watch that first video link that is there. Okay. There's a couple of other terms that we need to be aware of. The next one is something called a population parameter. Okay. Population parameters, they are just facts about the whole population. Okay. So a population parameter is just a fact about my whole population. So for example, a population parameter could be, let's say, 60% of the population is brunette. I'm not entirely sure that's true, but we'll take that as an example for now. So 60% of the population is brunette, okay? That could be a fact about my population, okay? You can also use like the mean of a population. So let's say, I don't know, I'm looking at like a mean IQ score for the population. That would be a population parameter. It's a fact about the population. We're going to look at standard deviation. That's another type of population parameter. But they're just facts about my whole population. Now, of course, as we've said before, finding facts about the whole population is incredibly difficult to do. So what we tend to find instead are sample statistics. Sample statistics are just facts about the sample that was taken from the population. So I take my population, I find a small random representative sample within my population, and I'm just going to survey that sample to find out facts about my sample. Okay, so if I surveyed my sample and found out that 60% of the people in that sample were brunette, that would be a sample statistic. It is a fact about the sample, not necessarily true about the whole population. We are just looking at the sample. So sample statistics are facts about a sample. Okay, so a big thing to remember here, okay, whenever you see sample, a fact about a sample is a statistic, and a fact about a population is a parameter. Okay, so statistics go with samples, parameters go with populations. Okay, so always remember it's that way around. The last couple of terms that you'll need to know for this course are two different types of statistics. First one is called descriptive statistics. Okay. Descriptive statistics summarize data in a meaningful way so that we can analyze it, but they're just summarizing data about the sample. We're not extrapolating it to the whole population. So descriptive statistics just describe the sample, not the whole population. Okay, so they don't allow us to draw conclusions about the population or beyond the sample. Okay, we just find statistics about the sample that is being analyzed. So descriptive statistics summarize data from the sample. So it could be, let's say, the mean of the sample, the standard deviation of the sample, a particular percentage of people in the sample that have a particular characteristic. Okay, they're summarizing data from that sample, but they cannot necessarily be extrapolated to tell us something about the population. Okay. There's a couple of reasons and a couple of instances where this arises. The first one is if you've taken a sample that isn't representative and wasn't randomly selected. Okay, you can find out statistics about the sample that you've got, but because it's not representative of the whole population, it's not going to tell us anything about the whole population. So that's an example when a descriptive statistic is used. And the other way that it can be used is it depends on the type of statistic that you are using. So we're going to see this again later on. This is just kind of an intro to it. But for example, the range. Let's say I was looking at numerical data. the range is the difference between the minimum value and the maximum value that you find within a population. So let's say you're looking at the height of a population, okay? If I took the range of heights from my sample, you tend to find the range of a sample is always smaller than the range of the population. It's just how it works with samples. It's very difficult to get a range that is equal to the range of the whole population. So range is a statistic that can cause some issues, okay, and where descriptive statistics are normally used, because you can't use a range to then extrapolate to describe a whole population, okay, because you may have, let's say, in a sample, your range of heights could be like 5'3" to 6 feet, but in reality for the whole population, it could be like 4'5" to like 7 foot something, okay, so you're going to end up with a much larger range, even if you try and be as representative as you can. So that's a descriptive statistic. The other type of statistic that you have is an inferential statistic. And this is one that can be extrapolated. So inferential statistics are where we take statistics from a sample and we extrapolate those to tell us something about the whole population. So these summarize. So they summarize data about a sample or from the sample to make generalizations about the population from which the sample was drawn. Okay, so descriptive statistics, we cannot infer anything about the population from those sample statistics. Inferential statistics, we can use that information, those summary statistics that we've got about my sample, to infer something about the whole population. So in this case, I would have a representative sample. It would be randomly selected. So if I had 60% of people in that sample were brunette, if it was randomly selected and it was a representative sample, I could say, okay, now I can infer that 60% of my population are also brunette. Okay, a very good example of an inferential statistic, it actually comes from looking at car safety ratings. So, for example, when I was buying my car a couple of years ago, a big thing that I was looking for was the safety rating of the car. Okay, I wanted it to be a very safe car. So my Corolla has a 5-star safety rating. Now, what does that mean? How do they figure that out? Well, you can't go to a car lot and say, okay, how safe is this particular car? Well, they haven't wrecked that particular car to find out how safe it is. What they have done is they've wrecked another one of those cars. So they've taken another Corolla and they've wrecked that and seen how safe it was. Okay, so let's say there's 100,000 Corollas in the US. Okay, what they've done is they've taken a sample of, let's say, 50 Corollas, and they've wrecked them and tried to do as much damage to them as they could to see how safe they actually were. Okay, they didn't wreck all 100,000 cars to see how safe each individual car was, because otherwise you'd have no cars on the lot left to sell. Okay, so to get a safety rating, they've taken a sample, they've wrecked those cars, and seeing what happens to that sample tells us something, hopefully, that we can infer about the whole population of Corollas. Okay, so a car safety rating is a classic example of something where they do use inferential statistics. Okay, they see how many of the cars in the sample survived the wrecks in order to tell us something about all 100,000 cars in the population. Okay, so just to sum up, descriptive statistics take a sample and describe properties just of that exact sample. They don't tell us anything about the population. Inferential statistics takes data from the sample and then allows us to infer something about the larger population from which that sample was drawn. Okay. those are all the terms you need to know for chapter 1. So you should now be able to do the 1.1 through 1.8 homework. It's all done as one chunk in Hawks. It's all one homework. So you should be able to do that now. If you have any problems whatsoever, please let me know, and please come to class on Monday, and I will see you either in class or in the next video.